Hello everyone, and welcome back to the channel. It's your host, ichino-ani here, and what a lovely day it is. Today is Monday, November 3rd, 2025. I've got a super interesting, trending paper from the Arcas for us today. It's a bit of a brain teaser, so get ready. The title is, Learning Pseudo-random Numbers with Transformers, Permuted Congruential Generators, Curricula, and Interpretability. Ooh, that's a mouthful, isn't it? The curl is also quite long. Chaps, colon//abs/2510.25792. So class, what is this paper all about? Imagine you have a machine that spits out numbers that look completely random. Well, no, like when you roll a dice. Ah, there's a secret. A machine is actually following a secret recipe to make these numbers. They're not truly random, they just look that way. We call these pseudo-random numbers. This paper asks a really fun question. Can we teach a super smart AI, called a transformer, to figure out the secret recipe? And not just any recipe, a really tricky one called a Permuted Congruential Generator, or PCG for short. Right, so these PCGs are used in many computer programs, so they're designed to be very hard to predict. They take the numbers from a simple recipe, and then, scramble them all up using complicated steps at bitwise shifts and rotations. It's like taking a secret message, and then putting it through a scramble multiple times. The big challenge is, can an AI student unscramble it and predict the next number? So what did the scientists do? They took a transformer model, which is amazing at finding patterns, and they gave it lots of these number sequences to study. Its job was to look at the first part of a sequence, and then guess the very next number. This is called in context learning, where the AI learns on the fly from the examples you give it. And you know, they found something interesting. When the secret recipe got really big and complicated, the AI student got stuck. It was like trying to solve a super hard math problem without learning the basics first. So they tried a new teaching method called curricular learning. Isn't that a great name? It's just like in school. You start with easy problems, like 1 + 1. Once you understand that, you move on to harder problems. They taught the AI with simpler recipes first, and then gradually introduced the more difficult ones. And guess what? It worked. The transformer AI successfully learned to predict the numbers from these very tricky, paired recipes. It could even predict them when parts of the number were hidden. That's amazing. That showed that this AI could crack codes that are designed to be tough, even for specialized computer programs. The scientists also discovered a rule, the scaling law. They found that the more complicated the recipe, or the bigger the modulus as they call it, the more examples the AI needed to see to figure it out. Specifically, the number of examples it needed grew with the square root of the modulus. This shows that these patterns are much harder to crack than simpler generators. And for me, the coolest part was when they looked inside the train's brain. They wanted to see how it was thinking. They found that the AI had automatically organized the numbers based on hidden patterns in their binary code. You know, their ones and zeros. It learned that things like how many zeros were in a row was a super important clue. It's like the AI discovered a secret alphabet for the code all on its own. Okay, so this all sounds very technical, right? Or why should we care about this? How does an AI learning to predict random numbers affect our daily lives? Well, let's think of a few examples. First, let's talk about online security. Pseudo-random numbers are super important for keeping us safe online. We're used to create the secret keys for things like online shopping, banking, or logging into your email. If an AI can learn to predict these numbers, it means our digital locks might not be as strong as we think they are. This research is like having a friendly super genius who tests our locks to see if they can be picked. It helps us understand the weaknesses and build even stronger security for the future. Second, think about video games and science. Right? Random numbers are used everywhere. In the video game, they decide where a monster will appear or what treasure you'll find in a chest. If those numbers weren't random, you could predict everything, and the game would be boring. And science researchers use these numbers to simulate everything from weather patterns to how diseases spread. If the randomness has a hidden pattern, the simulation could be wrong. An AI that can spot these patterns helps us build better, more realistic games, and more accurate scientific models. And for our third example, this research helps us build smarter AI. This whole experiment was like a very difficult test for the AI. By figuring out how to teach the AI to solve this hard puzzle, we learn more about how AI learns in general. The discovery that curriculum learning, this step-by-step teaching method, was absolutely necessary is a huge deal. We can use this same teaching strategy to help AI learn other complex things, like writing better computer code, or helping doctors find patterns in medical scans to diagnose illnesses earlier. It's all about finding better ways to be a good teacher to our AI students. So how does this AI compare to other technologies? Well, traditional ways of cracking these codes are very specialized. We're like a locksmith who only has one special key for one specific type of lock. These methods need to know a lot of information about the secret recipe beforehand. The transformer AI, on the other hand, is like a master locksmith. It can learn to pick almost any lock just by whittling it a whittle and seeing what happens. It figures out the secret recipe all by itself, just from the numbers it sees. This makes it much more powerful and flexible. This work shows that modern AI can uncover incredibly complex, hidden patterns in data. It's a little bit scary from a security standpoint, but it's also incredibly exciting because it pushes us to build better systems and understand intelligence itself. That's all the time we have for today. I hope you had fun learning about this. Keep asking questions and stay curious. This is ichino-ani signing off. See you next time.